There we go. Now we're going. That's not the presentation. Well, I just forgot to change my. All right, I forgot to change the title slide, so don't worry about it. So we're jumping in. We're jumping into threading. Anyways,
Is it live?
what's up?
Is it live already?
Yeah.
Oh, okay.
Yeah. I heard Brother Barney's getting the face full of my hot cha cha sound. That
Oh my gosh.
Yeah, I know. Actually, I'm gonna keep this up. That's actually relevant to what we're talking about. Why did I erase that? Neat. So have you guys messed with threading, multi-thread threading yet? I know threading is a little bit, but
Not mess with it.
Nay, I stand to you.
okay. You weren't a part of this subgroup yet, and so last week I was doing the socket stuff. Remember that? And I actually did some threading in there.
Okay.
I was doing the client and the server, so I was running the server in a separate thread, and the client was running like the main function and everything that kicks everything off, and the server was running on a different thread and everything. So the client ends up launching the server thread, which is like a dumb way to do it, but I was just doing it for learning's sake.
Right, I remember that.
In fact, totally don't like. I'm gonna talk to Brother Barney like what's the proper way to do like a P2P, a peer-to-peer sort of setup. We have a client and a server running on the same device. Obviously, I would assume that you'd want to be doing threading in that particular case. But I want to talk to him later. But when you're just doing regular server client stuff, you're just doing a client or a server, but you're programming both.
Yeah.
Instead of doing threading to test it out, to play with it and everything, it's a better idea to create separate projects for each one, and then actually create a new window of the server, a new window of the client in like NetBeans or Eclipse or IntelliJ.
Yeah.
And then you run each of those separately, and then they talk to each other like you ran completely separate apps. So
okay.
I feel stupid that I didn't think to do that, because like last week I was trying to talk to you guys. I'm like, I don't know how to do this, like the program server and the client, because I don't know it well enough. So if I make the server and export it as like a jar file and I can like run it and everything, I don't even know if it's gonna work. And then I have to go back and tweak it and re-export it. And I feel stupid that I didn't think just to run in two separate project windows. So when you're working on this and starting to learn how to do it, that's a more proper way to do it, is start up the server in one project and start up the client in another project and then talk.
That way they know they can talk.
Yeah, so when we're talking about socket stuff, so I brought that up in my threading thing. So try not to do it like I did unless you're just trying to understand threading and everything.
Okay.
And then at that point, Brother Barney told me yesterday, I did a fluency meeting with him, that it's probably a better idea to understand threading by implementing threading on your server project. And every time it gets a new connection, start a new thread.
Okay.
So that way you could have any number of clients connecting to that same server, and it starts up a new thread so that you actually have a concurrent execution. Anyways, do you guys know what threads are? I mean,
yeah.
You guys took OS 1, so you kind of have an idea of like what
I have a basic understanding.
Scheduling is like and how that works. So you generally have like one processor thread. For example, like let's say you have a single core machine, like an older machine, and you really have like one execution thread on the processor, and then it uses scheduling to figure out which process gets time at one particular spot and on the thread, right? Does that make sense?
Yeah.
Okay. So threading in Java is the same sort of thing. You have the Java process has its own thread, and when I say thread, I'm talking. It's kind of confusing because it's kind of like when I was talking about sockets and stuff. You have the operating system implementation and you have the Java implementation. So they're both different things. So sockets in Linux low level is the same concept, but a little different than the way Java deals with them.
Right.
In the same way that threading on the low level, so like dealing with scheduling and processing low level, is a little bit different than the way Java's doing it. So you have the scheduling and stuff low level, which a single Java process can run on, and then it gets scheduled the way that it would normally be. Then you have Java handling its own threading in its process thread. So don't get too confused on that. Just understand that there are some differences, and as you start to get into this more, you'll start seeing the differences.
Okay.
So don't worry about the operating system at this point. Just understand the concept of what a thread is and that type of thing. So enough of the baloney. Let's get into it straight away. So there's 3 ways that you can start a new thread or you can multi-thread. The easiest and simplest way is you actually have a class that extends thread,
Mhm.
So extends meaning that thread is an abstract class, and then implements is usually when something is an interface.
Right.
And so thread is an actual abstract class, and so you're going to be extending thread here. And you need to implement the run method, because that's where you actually stick all of your code that's going to be running in your single thread. So make sure it has to be called run. It can't be called something else. So that's very important. So public void run, and if you're using IDE, which you will be, NetBeans or something, it'll yell at you if you don't do the stuff properly. So it'll help you out if you kind of forget.
Okay.
So you create this new run method, which is overriding the method in the abstract class thread. And you put whatever code you want in there, whatever's going to run in the background. I just put a simple front line because
Just show.
Yeah. And when you do it in this implementation, you'd be sticking your main function here in the same class, and you can run it here. And so what we're doing here is we're instantiating a new instance of our class. So we call this class Spooler, and creating a new instance of it called Threading. And then what we do is we call the start method. So inside thread, the abstract class, there's a method called start that knows how to deal with run, that run method. So when you call start, what's actually happening is it's running this method. So you don't have to override start. Start is actually already in thread.
It knows
Worry about
what to
that.
do.
It inherits and it knows what to do. So this thing dot start is common in thread stuff. So kind of remember that. This is one way to do it. It's like the most basic way to do it, but it is not the preferred way to do it. So now let's go to the actual preferred way to do it. You've probably heard Brother Barney talking about runnables all kinds. Yeah, and you probably didn't know what it is. It's really, really simple. It's kind of like Java beans. Don't overthink it. All a runnable really is to you. The runnable class is an interface. And what that means, it's got a bunch of, you know what like a prototype is? It's basically saying what, it's kind of like if you're doing packages in the PL SQL, it's your package specification stuff.
Mm-hmm.
So what you're doing is you're saying the name of the function or the method, any parameters that it takes in, but you don't put any logic or anything. That's it. You're basically just saying, this is what the method is going to look like. So it's public void run, and then whatever's inside it as an example for like a prototype. And now with an interface, we use implements. Any class that implements your interface has to have those methods in there. But they can put whatever code they want in there. So just in case you were confused between like interfaces and abstract classes, because I was for like a really long time, and I'm starting to finally understand it. So kind of like the abstract class, with run over here, you actually have to implement it because it's part of the interface runnable. And all a runnable is just a package container for you to separate your code that you're about to run in the thread. That's all it is. So stick whatever code you want inside run and everything. You don't have to do anything else in the runnable. That's it. That's the whole runnable class. You can add more to it,
But you don't need to.
but all that has to be there is you just need to make sure you create a new class, implements runnable, make sure that run method is in there.
Yeah.
You can call it a day. So this is a way for you to modularize your code by sticking it inside a runnable class. So the only reason we're sticking it inside a class that implements runnable, just so I'm saying it properly. The only reason we implement runnable in the first place, as opposed to just making a generic class and calling run, is because this is the point of the interface, is you're required to have to put this run method in there. So it's kind of a way of quality assurance, making sure you're setting things up properly so that it runs well. So that's why we're doing that. So runnable, all it is, just a little container for you to stick your code in that modularizes so that you can run it in a thread later. That's all you really need to know. So I created another class main. This doesn't really matter what it's called. This is just one main function where it is loading. And right here, what we're doing is we're instantiating a new object. The class that we created up here called Spooler Run. So we're making a new instance of that called runner. And then right down here, we're creating a new thread object. I'm calling it thread. And then when we pass our runnable in on the constructor. So before we were just creating a thread, like I'll go back to the previous slide so you can see how they connect. So down here, all we were doing was we were extending thread, and then we were creating objects that have all the thread stuff in it. So now what we're doing is we're creating a generic thread object, and we're passing our runnable object into that. And the thread class knows how to deal with runnables and everything. That way, when you call start, it knows to run the run inside your runnable. Does that make sense?
Yeah.
Yeah.
You look like you're. I know. I'm probably not explaining this as clearly as I should be for beginner level stuff, but it is one of those things you kind of have to. Watch somebody explain it for a little while, and then eventually it'll snap together, and you're like, oh, okay, I get it. So really, all you need to understand again, runnable, just a container for your code. You're passing your container into a thread object, and then you call and start. That's
Okay. That makes sense.
long and simple of it. Now, that is the preferable method to do it. Now, there's another way that's not really better or worse. It's just another way to do it. It's kind of neat, actually. So you're running with the same idea of the runnable. Continue that idea. And you create a new runnable. This is like when I say that this is a modular way of doing things when I'm talking about the runnables, if you had a team of people and you wanted to create all these different threads and everything, and each thread does a different thing, one person could be working on a runnable that goes and talks to Google, and then another one could be working on a runnable that goes and does this thing. Then you have a person that works on getting all the threads running and cooperating. So it's a way of modularizing the code out so that it's really easy to work with. So if you were to just extend the classes and objects that you don't even know what the names are, you're like, okay, what's this object? Is this a new thread? So as you're looking through the code, you have no idea. Back in the previous slide, when we're creating a thread object, you can say, okay, we're creating a new thread here, and we're passing this runnable to just a better workflow.
For sure.
Now, what an executor allows you to do is an executor allows you to create a pool of threads that you can, basically you just call this execute method, you pass your runnable in there.
So it's like the start.
Yeah, it's the same sort of idea there. The execute here knows to call the run method inside your runnable. And the cool thing about the executor pool is the executor thread pool, it handles all of your thread overhead administration stuff for you, if I can kind of genericize it to that level. So basically, anytime you need a new thread, instead of having to create a new thread object and everything, you just run execute, it creates a new thread for you. It deals with closing the thread when it's done. So it handles some of the overhead. So all you have to do is just every single one time on a new thread, you just grab your pool object. So we create a new thread pool using this. And you just execute it, and it creates a new thread each time. So instead of having, again, to create a new thread object for each thing, just run execute, creates a new thread for you, execute, creates a new thread, and it kind of handles all the threads for you. So it's kind of just an interesting way of doing it. So if I was creating a server that would create a new instance, or a new socket, a new thread for each new connection, I would probably want to use an executor pool, a thread pool, and every single time I get a new connection, I just run execute, and it'll go through and do that. So it's just another way of doing the same sort of thing. A lot of threads. If you're not going to be creating a lot of threads, just maybe a couple, this is a better way to do it. Just a little bit more simple. Create a new object, run start.
So they generally do the same thing, but it's important to understand the difference between them because every time you're doing whatever you're threading, whatever, it's going to be different.
Yeah, because if your program only makes 3 threads maximum ever.
Yeah, why would you be pooling all the time?
Yeah, but if you're creating a web server that's going to be handling thousands of connections and possibly starting thousands of threads,
Okay.
you don't want to be doing this.
That's something.
I think the runnable of those is what I like the best.
Well, always use, they're both using runnables, this one
I'm in this one.
and this one. Yeah, this is kind of just a standard method. This is good for a couple of threads. If you're creating an application where you don't know how many threads, actually that's probably a better way to say it. If you're creating an application that will be creating threads but you don't know how many, then use your pool.
Right.
If you know exactly how many are going to be there, use this method. Just creating a flat thread, a new thread object, and pass your runnable into it and start it. If you're not sure, like with the web server, you're not sure how many people are going to be in that connect, use the thread pool. So that's probably actually a better way to look at both of these. Have you guys seen my code by any chance?
I think I saw it last week.
Okay. You guys don't have anywhere to, well, no, you're Lex Society. Aha, so you're staying. Let me just show you what my code looks like so you can kind of see this in action. It's the same code from last time, actually. I just added some stuff to it and made it a little cleaner. Let me change my screen. I don't know, it's drunk. That is interesting. I will just change it to desktop. It doesn't know about my different workspaces, the little screen share thing. It won't look at different workspaces. Anyways, I am in the wrong project. Sorry, everybody. All right, let me open up my my Bean Trader project, the one from last week. Sorry, I thought I had this open already. I know, I feel like a dingus. I do. I don't like Eclipse and NetBeans because I think they're too cluttered. There's like a million things all over the place. It's even hard to even think in there.
That's so true.
IntelliJ is really, really clean, and I like it. And another reason why I'm opting for IntelliJ over Eclipse is that Android Studio is running on IntelliJ, and it looks like Google's going to be making Android Studio its new like Android IDE of choice in the future. And so it would make a lot of sense to be more proficient in IntelliJ than Eclipse at this point. Now that it looks like Google might be the new Android platform thing. So anyways, let me open up. By the way, this is the project I'm using your Java Bean, Jordan. Yeah, boo. Okay. Let's do new window. Okay. So this is the little socket thing that I had. We have a server and a client. The client sends a Java Bean to the server, and then when the server receives that Java Bean, it sends another Java Bean back to the client. Anyways, I was telling you a little bit, that's why I kind of started talking about that at the beginning, because Jeremy wasn't there last week. I was too stupid to think, create a server project and a client project. So I'm like, how do I learn how to do a client and server in the same project without having to export a server and then create the client? So what my awesome solution to it was to launch a server in a different thread so that I could then mess with it there and whatnot. So I was creating the runnable. So let's go to my runnable class for this project so you can see what it looks like. I just called my class server run. So you can see I implemented runnable. That's, just remember, implements, not extends. And honestly, it'll probably yell at you if you use the wrong thing anyways, because thread is not an interface, it's an abstract class, so it'll probably yell at you.
Well, I would say you can just,
yeah. So again, the only thing you really needs to implement runnable, and it needs to actually implement the run method. And you see, just put a bunch of code in there. I didn't have to do anything special with run. I didn't have to put any weird, crazy crap up here in the signature for the method, and have to pass any parameters in. Just straight up.
Just straight run.
Yeah. And something to, I guess this is actually pertinent to what we're talking about. Something important to note is it's not usually a good idea to have Java kill threads. Now, you can do that. There's a way to thread start and then thread stop, and there's even a terminate and a bunch of others and stuff. Brother Barney and the rest of the world seems to be very adamant about the fact that you should not have Java stop a thread. Technically, if Java starts a thread, the thread should be running until the whole program stops, and then usually that's the operating system killing it. And anyway, he's of the opinion that if you're having a thread running, especially if it's a server or something, you should have the server running 24/7. You should never have Java, like in my code here, which is why every time I talk to his brother Barney about this, he started cringing every time we were showing him things I was doing. He's like, oh, don't do that. So this was a server that was running and waiting for a connection. Everything had a while loop down there, and I was actually having the thread stop and everything. It's like, yeah, don't do that. The reason being is the code could be at any level of execution or any point of execution at the moment that you kill it. And when you kill it, you might have memory problems. Like you haven't dealt with cleaning up the memory and everything, and the thread just stopped. You have stuff, you have clutter now that's out there, and it's a poor way to do it. So a lot of times, if you're creating a thread, the thread should run for the entire duration of the program you're running, and then the program closes and deals with all of the garbage, I guess, the Java garbage. Yeah, it'll deal with that and make sure all the threads cleaned up properly and everything. So a way to get around that for a server that I'm running, like I'm running for the duration of this project, but I actually want to be able to have the client stop it for whatever damn reason. You want to kill the thread like normal. You just want to create a loop in here, like an event loop, and then just kill the event loop. And then when there's nothing left in the code, then the thread will automatically close itself. And that's kind of the idea, because the thread will only stay open for as long as there's code being run in it. Right. So if you have a while loop that's running in there, and you set while true, it's an infinite loop, and it'll run forever. Not a good way to do it because there's no proper way to close it without force closing the thread. Mm-hmm. So I have a while loop down here, and I passed in a variable called running, which is just a Boolean true false sort of thing. And I created a new method up here called kill, And what I do is instead of killing the thread from my client, I just call the kill method, and it goes in here and changes the Boolean value in my while loop, and it shuts down the while loop, and then thread execution has stopped, and so the thread gets garbage collected and killed back and brought back in. So just kind of, I went over a lot of details there. Just remember, don't manually kill a thread inside Java. If you do create a server, and servers are supposed to run forever, the proper way of killing that server at that point is to kill it from the operating system, Control-C or something, if you're running a terminal. I was talking to Brother Barney about that. I'm like, well, if I do make a server, what's a good way to kill it? He's like, Control-C. That's the way you want to do it. You want to have the operating system handle that, not Java. Because if you have Java do it, you now have to implement a lot of logic in there to clean everything up.
Yeah.
So that's the idea behind it.
It's just unnecessary, and it makes
it's unnecessary. It's way too much work. It's not a good idea. So while the terminate method and all of these other methods to stop a thread exist, they're all like anytime you go to an API that talks about all of the different thread methods and everything, it'll say deprecated in big red bold letters, don't use this kind of thing, even though it still exists.
Right.
So I just showed you my runnable, implements runnable, that's all you need to remember, and then actually we implement the run method or override it. Then we actually have, this is my client program. Don't bother looking at all this stuff here. This is all I need to really look at. So I actually have the runnable example that I had, the standard runnable that I'm actually creating a thread object. That's right here. So all I'm doing is I'm taking the server run runnable I'm just showing you. I'm instantiating a new instance of it. Then I'm creating a new thread object, and I'm passing in my runnable into the constructor there. And then I'm calling the thread object dot start. Yeah, what's up?
I want to say something. If you have a thread and you call .run, it will technically do the code. However, it will not put it into a new thread.
Mm-hmm.
I just ran into that. That was my issue that I was running into.
You did not run instead of start.
Yes.
Okay.
.start calls run in a new thread.
Yes.
.run calls run in the current thread,
Current
Use
thread,
start.
even though it's a thread object.
Yeah. So don't use run.
So don't use .run on a thread.
Just put all the code inside run, create the method and everything, and then forget about it.
Okay.
That's pretty much what it comes down to.
Okay.
Then in the comment here, I have the example for how this would be done with an executor. So same idea behind it. We're talking. This is literally all just 2 lines that needs to be done. So you need to create a new thread pool. So that's using this. This is kind of something you just have to memorize. It's kind of a long method name.
No space.
Executors. And yeah, if you're using IDE, that's one of the nice things about it. Is you
New
have
dots,
that
control
drop down
space.
menu that comes up.
It shows you all.
It shows you all the methods that are connected to a particular object or a particular class or something. So it's executors, plural, remember that one. Dot, new cache, and this is in this book.
Okay.
Oh, it's executors .plural. That's weird.
Yeah, executor class and executors has the new cache thread.
Yeah, I'll have to memorize that.
Our ones are ended. Then, once you have the spool object, you execute the execute method, you call that, and you pass your server runnable there. Like I said, the reason why you want to use a thread pool as opposed to the other method is when you're probably not sure how many threads are going to be created. Again, in a web server, not sure how many connections you're going to create. Or if you know you're going to be doing a lot of threads. Even if you know exactly how many there are, this is still probably a better way to do it for that. So
It also, one of the things about the thread pool piece you were just talking to me about, if you're creating threads by themselves and then closing them, right? That actually well, Java does some smart things to keep it around, but a thread pool, it will all the threads that get closed, they can just go back to the pool and wait to be used again. Yep. So they're allocated once and then used later.
But again,
Threads are allocated when you create them.
But again, try not to close threads. I'm not sure if he's talked to you about that.
Yeah.
That's a bad idea. You want to wait for the code to finish executing the thread and then let Java kill the thread for you, and then do all the garbage collection required. If you stop a thread, there's stuff in memory that hasn't been cleaned up by you, and it's just kind of a dirty way to do it. So he's just been reiterating over and over with me: don't kill a thread manually. Don't do it. Just forget that's a possibility. Instead, implement other logic like an event loop if you're going to keep the thread open for a certain amount of time. Then create logic that closes the event loop, and then when the execution of the code is finished in the thread will then close, and then be collected back up into the pool within an executor thread pool. So that's kind of the way that you'd want to do it. And Yeah, if you wanted to kill it at all. But again, if you're running a server, for example, something that's going to run for a while, you want to have the operating system kill it and not Java. So just best practices. So does anybody have any questions on anything that I've gone over? I went over a lot of stuff. Is there anything you guys wanted me to discuss a little bit more in detail, or I didn't explain it very well and you'd like me to go into it?
So if you're going to use execute with an anonymous runnable,
Yes.
would you just define it right in there? It's like where you have server runnable.
Yes. It would be
The
the
server
same.
run is type runnable, right? So
Say what again?
server run.
Server run in this case
is a
is-
runnable. It implements
It
runnable.
implements runnable. Yes.
Okay. So that's where you would actually be putting your anonymous runnable is or inside your execute, right?
Well,
Execute.
I didn't create a new server run class.
Yes, that's what I'm
Yes,
saying.
yes, that's what I would be doing. It that's why I kept this code up here. Kind of shows you an example. This, by the way, this is part of an example he was doing in class on how to pass things between using background threads to update the UI inside Android. So if you have something that needs to happen in the background, like you need to go to weather.com and use their API to get the weather or something, you don't want to have you want to run that in its own separate little instance, and then you can have that update the UI by using handlers and stuff. I'm not going to go into that too deep because I feel like I've given you a lot already.
Yeah, no,
The main reason I was keeping this up here is just showing you can use anonymous classes in here. Do you guys know what anonymous classes are? Instead of actually creating an actual new class file and everything, you don't actually name it or anything. You just pass it in as an argument. The name of the object. So right here, I created server run, and I call server runnable here. Instead of doing that, I could have not made server run code up there. And I could have just done right here where I'm creating a new thread. I could have done new runnable. And then I would put all the code in there. And then implementing the thread method and everything. And I could have just put it all.
that's called an anonymous class.
That's an anonymous class, and you're passing in all of the class instantiation code into it as a parameter, I guess. So you're not giving it a name or anything, so you're not naming it. You're not creating a separate object variable for that. You're just putting all of the code that you need to create an object within the parameters, or sorry, in this case, you're executing, so it's arguments of that method. So, does that make sense? Because if it doesn't, I'll go over something, but it's just something you just want to play with. It's really easy to get started. I have this presentation I was using on Google Drive, so you can go in there and see the code examples. And everything I stuck in the Google Drive, I just wrote here in like 1 minute as Jeremy was presenting. Well, I didn't have the presentation ready yet.
Well, I saw
It was towards the end when we were pretty much done. But my point is, it was really, really easy to write, and everything that I put in there is all you need to create it, to create new threads and everything. So literally, this is all the code you need to do that stuff. So let me go up to, there we go. That's all you need to do to create a runnable. Literally, that's it. There's no, I'm not leaving any magic away from you or anything. I literally added everything you need to do to make this go.
And that's the Google Drive.
Yes. So it's also in this book. So read through the chapter on threading. It'll help you understand some of these things or confuse you more. I don't know.
Yeah.
This presentation is like a getting started tutorial. If you just want to jump into it really quickly and learn as you go. That's what I say.
Okay.
And there's a lot of other stuff that you can know about threading. Like you can name a thread when you're actually creating a thread object here, a second argument here. You can actually name the thread. And so if you want to reference what thread something is in, by a name, you can actually use a get current thread method, I believe is what it's called. And then dot get name, you can get the name of the thread. Okay, so anyways, that's extra. That's pretty much the intro to threading. Stop it. Thank you.